Okay. Welcome, my students and viewers. What is visible from the trend of my videos are students are liking this MCQs videos or the MCQs classes. So for few another days, few 10 days, I'll be posting one video daily for MCQs, handling different types of sums. So today once again I am here to solve few MCQs, few sums. Let us start. And first is, if consumer price index for April 2015 was 120 and in April 2016 it increased to 126, find percentage rate of inflation. So percentage rate of inflation is change in CPI, consumer price index, divided by initial CPI and into 100. From 126 to 120 to 126. So 126 minus 120, this is change in CPI, and divided by initial CPI into 100. So 6 by 120 into 100. So rate of inflation is 5%. Yes. So 5% is the rate of inflation. So this is how when this consumer price index for 2 periods are given, then rate of inflation, of course, in the form of percentage is being found, that change in CPI divided by initial CPI into 100. This is how we calculate. Second question, in an open economy input-output model, the Leontief matrix I minus A is viable when? Yes, in input-output analysis, what is initially given is a technology matrix A. Let 2 by 2 technology matrix A is this one. This is called technology matrix. Now Leontief matrix is defined as I minus A, that is identity matrix minus A and so 0.6 minus 0.5 minus 0.3 and once again 0.6. Now this I minus A matrix would give the viable solution if this I minus A is positive. What is found here? 0.6 into 0.6, 0.36 and 0.36 and 2 minuses. So once again minus. So 0.15, 0.21 positive, it is viable. The same condition could be stated as all the principal minors are positive. In 2 by 2 matrix, there are 2 principal minor. Principal minor 1 is top element positive, and every matrix is its own principal minor. So principal minor 2 would be the entire I minus A matrix determinant value 0.21 positive. So this is fulfillment of this condition, and this condition is known as Simon-Hawkins condition. Simon-Hawkins condition. So the answer would be I minus A has to be positive. That fulfills the Simon-Hawkins condition. And secondly, and all the principal minors are positive. Both are the same statement. So all the principal minors are positive. So this is answer and this will be the answer. Now this is related to consumer surplus, which will involve a little bit of integral calculus. Here we are given the demand function, and at a particular price we have to find the consumer surplus. So this is the demand function, and quantity is given as 3. This is demand function. So corresponding to this quantity, we shall calculate the price and this is consumer surplus. Now, demand function is P 27 minus 3x minus x square. Now x is 3, so put x in here. So take it x0, so that will be P0, 27 minus 9 minus 9, so P0 is 9. Now this is the formula. Consumer surplus is defined as from 0 to x0 P dx minus P0 x0. So little bit of this definite integral would be used, and here 0 to 3, 27 minus 3x minus x square dx, and minus P0 into x0. So this is 3 into 9. Now this has to be integrated. 27x minus 3x square by 2 minus x cube by 3. This is definite integral. No integral constant c would be taken. So 0 to 3 and minus 27. Now we put the upper value in all these three fractions. So 27 into 3 minus 3 into 9 by 2 minus 27 by 3 and minus 27. So if we LCM, so that will be 81 minus 9 into 3, 27 and 3, 81, 54 and once again 81. So that is 486 minus and divided by 6, and this is consumer surplus. So this is how just we calculate the consumer surplus when we are given the very demand function and initial this demand or price is given, then we can have the value of consumer surplus, and this area is 270 by 6. This is cobweb model, and it is not in a standard form. QS is alpha plus beta PT minus 1. Absolutely in cobweb model, we have 1 period lag in supply function and no lag in demand function, but this demand function is not in a standard form. So to have the knowledge, this has to be a little bit restructured. So function is given as QS is alpha plus beta PT minus 1, and this demand function has to be rearranged. So delta QD is gamma minus PT, hence QD is gamma by delta minus 1 by delta PT. This is QD and this is QS, alpha plus beta P. Now this cobweb model has become in a standard form. The analysis of cobweb model, if required by the students, I'll make a separate video on this cobweb model, that too in quite detail. Cobweb model states that in a cobweb model we have the stable equilibrium. In cobweb model, because time path is oscillatory, so we have the stable equilibrium when absolute slope of demand is larger than absolute slope of supply. This is the condition of stability of the cobweb model. When absolute slope of demand happens to be larger than the absolute slope of demand. Now, the absolute slope of demand is 1 by delta. And absolute slope of supply is beta. So when 1 by delta is greater than beta, or 1 by beta is greater than delta, both are the same statement, then we shall have a stable oscillation in cobweb model. And answer, delta is less than 1 by beta, and this is the answer, delta is less than 1 by beta. So in cobweb model we have a stable oscillation of the price, or the time path of price is stable if absolute slope of demand happens to be larger than the absolute slope of supply. This is the stability condition of the cobweb model. And here we have the slope of demand 1 by delta, slope of supply 1 by beta. So 1 by delta has to be larger than beta, or 1 by beta has to be greater than the delta. This is the answer. Delta is less than 1 by beta. This one. So this is the answer. Solving another sums. This is the fifth question. Correlation coefficient between y and x, Rxy, is 0.6. Then which of the following conclusions are true? In this context, if y is a function of x and Rxy becomes 0.6, then R square is 0.36 or 36%. The total variation of the total variation of y, 36% is being explained by x, and the rest 64% is explained by the random variable. So here, since Rxy is 0.6, so we have the answer that 36% of the variation in explained variable or the dependent variable is explained. So this A would be the answer. Number 6. Find out the value of Gini coefficient for estimating industrial conclusion using formula. By using this formula, we have to find the Gini coefficient when the industrial production of 4 industries are given here. This G is 1 by n summation n minus 2i plus 1 into SI. I is a ith industry and SI is the very contribution of ith industry. We have the 4 industry F1, F2, F3, F4, and these are the individual contributions by all the 4 industries. So this is the value of SI. The S1 70, S2 10, S3 10 and S4 10. Now for this will be calculated in this way. G, that is 1 by 4, and for all the 4 industries this formula has to be N4 minus 2 I is the first industry, so 2 into 1 plus 1 and into contribution of first industry 70. For second industry 4 minus 2 into 2, formula 2i, I is the industry's position. So this is second industry, so 2 into 2 plus 1 and the very contribution of F2 is 10. Similarly for third industry, N minus 2 into third industry, 2 into 3 plus 1 and into contribution of third is 10, and this is 4 minus 2 into 4, fourth industry plus 1 into 10. When this is solved, we reach at the conclusion that the Gini coefficient is 45. So this is 45 by using this formula. Now formula here, this sum number 7. If 2 lines of regressions are this one, find Rxy. In this context, there is a theorem that for 2 lines of regression, y is alpha plus beta x and x is a plus by, then R is defined as the geometric mean of beta into b. That is the geometric mean of 2 regression coefficients happens to be the correlation coefficient. Now in these 2 regression equations, one regression coefficient is 0.4 and the another regression coefficient is 0.9. So R would be under root 0.4 into 0.9, that is 0.36, and so R value would be 0.6. So this will be the answer. This is how it is calculated. Our 8th sum is, if byx is 0.4, that is the regression coefficient of y on x is 0.4 and the regression coefficient of x on y is minus 0.4, sorry, minus, mind it, sine is minus 0.4 and bxy is minus 1.6. Find rxy. R is plus minus under root byx into bxy. That is plus minus under root 0.4 into 1.6 plus minus 0.64 plus minus 0.8. Now, the sign of R would be stand in equality of the sign of these two regression coefficients. Both regression coefficients are negative, hence R would be negative. Yes, minus 0.8 instead of plus 0.8. Ninth sum, value of chi-square in 3 into 5 contingency table. A test of no association is to be performed. The degree of freedom shall be. Here, one thing has to be remembered, that if contingency table is 2 by 2, then degree of freedom is 1. But if contingency table is R into S, row into column, then degree of freedom would be R minus 1 and into S minus 1. This is the formula. Now contingency table we have 3 into 5. So 3 into 5, degree of freedom would be 3 minus 1 into 5 minus 1. So 2 into 4, and that is 8. So degrees of freedom while testing would be taken as 8 in a chi-square test. With the help of chi-square, two most important tests are being performed. One is the goodness of fit, and second is the independence of attributes or association, independence of attributes. So while this testing independence of attributes or a degree of association, we have the contingency table, and so if contingency table is 2 by 2, degree of freedom is 1, and if the degree of the contingency table is Rn2s, that is 3 into 5, then degree of freedom would be 3 in minus 1 into 5 minus 1, that is 8. This is what. Question number 10. Assuming life cycle hypothesis that was given by Ando Modigliani by explaining various theories of consumption function, and after Keynes's psychological law, various theories of consumption appeared in macroeconomics, and one important theory was given by Ando Modigliani, that is life cycle hypothesis. Question says that in assuming life cycle, a person starts working at the age of 20 years. A person starts working at the age of 20 years. He retires at 60 and expects to die at 70. Starts working as 20, retires at 60, and he is expecting his death at 70. If he earns 1.5 lakh annually in 20 to 30 years lifespan, 2 lakh in 30 to 45 years while he was, and 3 lakh when he was 40 to 60 years. His lifetime APC will be average propensity to consume lifetime would be. In this context, there is one formula, and formula says that Y into R minus S equals C into D minus S. Y is income, C is consumption, R is the retirement age, S is the working starting age, D is the death age, and S is the starting age. Everything is given in the sum. So Y, retirement age is 60. So 60 minus 20, he starts working as the age of 20. So Y into 60 minus 20 equals C, death age is 70, starting age is 20. 70 minus 20, we have to find the APC, and APC is C by Y. So C by Y would be 60 by 20 divided by 70 by 20, 40 by 50, and that comes to 0.8. So his lifetime average propensity to consume would be 0.8. So this is how we have solved this 10 sums In my next video, I shall be solving another more sums. But for today, this is all. And if in these all contexts, students have any problem in any kind of queries, they must ask me. I am expecting questions and queries from the students. If the students are having any problem anywhere. So this is all for today. From right next day, tomorrow, I shall be coming out with more sums. This is all for today. Thanks.